Now, we are to solve the components of a certain vector x given this equation here, and that the given vectors u, v, and w with its corresponding components. So we can actually work on this. This is already given, and this as well, and this as well. But this entire expression here is dependent on the components of vector x, which will make the entire equation true. Since we don't have the exact value for vector x, let's represent it in this manner. We are going to consider vector x, and that's what we're looking for. Its component is also a component of R4, because our vectors u, v, and w are in R4. So we will try to use here x sub 1, x sub 2, x sub 3, and x sub 4. Now, we can actually automatically implement all, substitute all values here for our the components of each vectors. But let me try to attack it slowly by slowly. So we are going to start first with the left hand side. We have 3 u plus v minus 2 w. Alright? 3u means there is a scalar value to be multiplied with the entire vector u. So you have negative 3, 1, 2, and 0. This is to be added with the vector v, which is 4, 7, negative 3, and 2. And then you have minus another scalar 2 for your vector w here, which stands for 5, negative 2, 8, and 1. This means that the left hand side would have this computation. If you have your scalar, simply multiply all entries. So you have negative 9, you have 3, 6, 0. This is still 4, 7, negative 3, and 2. And here you have minus 10. Take note that we are only distributing 2. We are not using the minus here yet. So don't forget that it will happen like this. You will have negative 4. You have positive 16 and 2. Then you can now implement all of this. So you have this expression here, negative 9 plus 4, all the first entries, minus 10. Second, 3 plus 7 minus, you have negative 4. Next, you have 6, and then minus 3, and then you have minus 16. Next, you have 0, then plus 2, and minus 2. This means for your left hand side, you have negative 15, that's the result here. Then double negative property plus positive 14. This is negative 13, and you have your 0. For your right hand side, let me use the spaces here. So you have 3x plus 2w. Notice that x doesn't have exact values for its components, but we will be using this representation. Therefore, you have 3 times x sub 1, x sub 2, x sub 3, and x sub 4. Plus 2, your w is as it is, 5, negative 2, 8, and 1. This means that we have here 3x sub 1, 3x sub 2, 3x sub 3, 3x sub 4, plus 10, negative 4, 16, and you will have your 2, which will give us a result, which is 3x sub 1 plus 10. Then 3x sub 2 minus 4. 3x sub 3 plus 16. 3x sub 4 plus 2. So this is our right hand side. We already have our left hand side earlier, and we're going to combine them into one equation. So you have here negative 15, 14, negative 13, and 0 equal to 3x sub 1 plus 10, 3x sub 2 minus 4, 3x sub 3 plus 16, and 3x sub 4 plus 2. Okay? So we can use now equivalent vectors, and by symmetric property we'll have these equations. 3x sub 1 plus 10 is negative 15. Next, 3x sub 2 minus 4 is positive 14. 3x sub 3 plus 16, that's 16, is negative 13. And 3x sub 4 plus 2 is 0. So we solve them separately. You have 3x sub 1, subtracting both sides by 10, you have negative 25. So x sub 1 is negative 25 over 3. Next, adding both sides by 4, 3x sub 2 is 18. Dividing both sides by 3, x sub 2 is 6. Next, subtracting both sides by 16, 3x sub 3 is equal to negative 29. So x sub 3 is negative 29 over 3. And finally, subtracting both sides by 2, 3x sub 4 is negative 2. So x sub 4 is negative 2 thirds. With all of these values for x sub 1, x sub 2, x sub 3, and x sub 4, which are all the components of vector x, the vector that we're solving for, the vector x now has components equal to negative 25 over 3, positive 6, negative 29 thirds, and negative 2 thirds. Now we have already solved the components of vector x using the declared equation and the already available components of vectors u, v, and w. Please consider the appropriate operations, including the scalar under multiplication, and you will need to consider as well the equality of vectors. Thank you for watching.